Normandy, France. June 6, 1944. The beach designated Sword is a killing ground. German machine gun positions, concrete pillboxes, and reinforced bunkers command every approach. The tide is coming in, and men are dying in the surf. Then, from offshore, something peculiar happens. A Churchill tank rolls off a landing craft, but instead of tracks clanking against metal, there's the distinct rumble of diesel engines paired with something else entirely. The tank doesn't advance with its gun blazing. Instead, it positions itself at a careful angle to a German strong point and begins to rotate what appears to be a massive cylindrical drum mounted to its front. The drum spins faster, faster still, until it becomes a blur. The tank inches forward. When the spinning cylinder makes contact with the concrete wall of the pillbox, there's no explosion, no dramatic detonation. Just a peculiar grinding sound, almost mundane as the concrete begins to disintegrate. Within minutes, the fortification that had held up an entire company of infantry simply ceases to exist as a defensive position. The men inside, deafened and disoriented by the vibrations, emerge to surrender or flee. This is not a weapon of fire and fury. This is something altogether different. This is the story of how British engineers weaponized physics itself, and in doing so, created one of the most unusual and effective siege weapons of the Second World War. The problem confronting Allied planners in the years before D-Day was brutally simple. The Atlantic Wall was real, and it was formidable. From Norway to the Spanish border, the Germans had constructed thousands of defensive positions, many of them concrete fortifications designed to withstand sustained artillery bombardment. These weren't hastily constructed earthworks. These were engineered structures with walls often exceeding 1 meter in thickness, reinforced with steel rebar, positioned to provide overlapping fields of fire. Intelligence estimates suggested that breaching the beach defenses alone could result in casualty rates approaching 70% in the initial assault waves. Traditional demolition methods required engineers to approach under fire, place explosive charges with precision, withdraw to a safe distance, and detonate. In the chaos of an amphibious assault, with men struggling through surf and sand whilst under continuous machine gun fire, this process was effectively impossible. Artillery bombardment had proven insufficient. The Germans had learned from the Great War. Their concrete bunkers could absorb direct hits from naval guns without catastrophic failure. Even when damaged, the positions often remained operational enough to continue firing. Aerial bombing was imprecise at best, and the need to minimize French civilian casualties limited its application. Flamethrowers could suppress a position temporarily, but concrete doesn't burn. The mathematics were stark. Each fortified position might require dozens of casualties to overcome through conventional infantry assault. Multiply that across hundreds of defensive positions, and the invasion itself became questionable. Something radical was needed. Something that could approach these fortifications directly, survive the defensive fire long enough to neutralize the position, and do so without requiring dismounted engineers to expose themselves to certain death. The solution would need to combine mobility, protection, and a means of destruction that didn't rely on explosives that could be disrupted by enemy fire or fail in the wet conditions of an amphibious landing. The answer emerged from an unlikely source. Major General Percy Hobart, a brilliant but controversial figure who had been effectively retired from active service, was brought back and tasked with developing specialized armored vehicles for the invasion. His headquarters, the 79th Armored Division, became a laboratory for unconventional warfare. Among the various innovations developed under Hobart's direction, one stands out for its sheer audacity. Engineers had observed that heavy machinery fitted with rotating drums could break up road surfaces and concrete with remarkable efficiency. The principle was simple physics. A heavy cylindrical drum, when rotated at high speed and pressed against a surface, generates tremendous force through continuous impact. Each rotation delivers thousands of small hammer blows. Against concrete, the effect is cumulative and devastating. The challenge was weaponizing this principle. The solution was designated the Armored Vehicle Royal Engineers, or AVRE, fitted with what became known as the bobbin and carpet layer attachment in some variants. But more significantly, the Churchill AVRE, fitted with the conger, and later the specific variant known as the AVRE, with the explosive device called the petard. However, the truly non-explosive solution was the AVRE variant, fitted with fascines and, crucially, the attachment we're concerned with: a powered rotating drum mechanism. The actual device, developed at the Department of Tank Design and tested extensively at the Fighting Vehicle Proving Establishment in Chobham, Surrey, consisted of a heavy steel drum approximately 1.8 meters in diameter and 2.4 meters in width. The drum weighed roughly 5 tons and was powered directly from the tank's engine through a modified power takeoff system. The rotation speed could reach up to 40 revolutions per minute, though operational speeds were typically maintained at around 30. The drum's surface was fitted with hardened steel teeth, each approximately 15 centimeters long, arranged in a spiral pattern to ensure continuous contact. When spinning at operational speed and pressed against concrete with the full weight of a 39-ton Churchill tank behind it, the device generated impact forces equivalent to hundreds of sledgehammer blows per second. The concrete didn't shatter dramatically. It simply pulverized, turning to dust and aggregate under the relentless mechanical assault. Manufacturing took place primarily at the Royal Ordnance Factory and various subcontractors throughout the Midlands. Exact production numbers remain classified, but estimates suggest somewhere between 30 and 50 units were produced in time for the Normandy landings, with additional variants developed for specific obstacles. On the beaches and in the bocage country beyond, these machines proved their worth in ways that surprised even their creators. At Sword Beach, crews reported approaching German positions that had already been struck by naval gunfire without significant effect. The rotating drum systems reduced these same positions to rubble in under 10 minutes. The psychological effect on German defenders was pronounced. Explosions, however violent, were familiar. Soldiers had learned to endure bombardment, to take cover, to wait it out. But the grinding, relentless approach of a tank that didn't need to fire, that simply drove forward and destroyed concrete through mechanical force alone, was profoundly unnerving. Reports from interrogated prisoners consistently mentioned the terror of hearing the grinding sound, feeling the vibrations through the structure, watching cracks spider across walls they'd believed impregnable. Several positions are surrendered before the drum even made contact. In the weeks following the initial landings, the devices proved particularly valuable in urban combat. Norman towns and villages were often built around stone structures that provided excellent defensive positions. Traditional explosives risked bringing down entire buildings, potentially blocking streets and creating rubble that actually aided defenders. The drum mechanism allowed for surgical destruction of specific walls or firing positions whilst leaving the overall structure largely intact. If you're finding this interesting, a quick subscribe helps more than you know. The Germans had attempted their own solutions to fortification breaking, but nothing quite matched the British approach. Their primary answer to concrete obstacles remained explosives, specifically large-shaped charges carried by dedicated assault engineers. The Goliath tracked mine, a remote-controlled explosive device, proved vulnerable to small arms fire and was too slow to be reliably effective under combat conditions. The Sturm Tiger, mounting a massive rocket-propelled demolition charge, was certainly dramatic, but required only 38 centimeters of concrete to defeat most fortifications, and its limited ammunition capacity meant each vehicle carried only 14 rounds. By contrast, the British drum system required no ammunition, could operate continuously as long as fuel remained, and was immune to the damp conditions that plagued explosive fuses. The Americans developed their own specialized engineering vehicles, notably the M1 dozer blade fitted to Sherman tanks. But this was primarily intended for earth-moving and obstacle clearing, rather than fortification destruction. They relied more heavily on concentrated artillery fire and, increasingly, on direct fire from tank destroyers and self-propelled guns. The British system's uniqueness lay in its mechanical simplicity and its independence from explosive logistics. Where American forces might call in an artillery barrage, requiring coordination, ammunition expenditure, and accepting the risk of shells falling short, a British AVRE could simply drive to the problem and methodically destroy it. The concept was studied extensively by Soviet engineers, who incorporated similar principles into their post-war engineering vehicle designs, though they typically favored explosive approaches for immediate battlefield application. The actual impact of these weapons on the campaign's outcome is difficult to quantify with precision, as wartime records focused more on objectives taken than on the specific means of taking them. However, after-action reports from units supported by the specialized armor consistently note reduced casualties when breaching fortified positions. Where conventional assaults might cost a platoon to take a single bunker, AVRE support often meant the position fell with minimal friendly losses. The psychological dimension cannot be overstated. The Atlantic Wall was as much about deterrence as defense. It was meant to make the Allies believe invasion was impossible, to delay any attempt long enough for German reinforcements to arrive and destroy the beachhead. When that wall proved vulnerable to weapons that didn't even need to fire a shot, the psychological calculation shifted. Defenders who might have held out against conventional assault, believing time was on their side, instead chose surrender when faced with the methodical destruction of their positions. The technology's influence extended beyond the immediate tactical situation. Post-war civil engineering adopted and refined similar principles for demolition work, particularly in situations where explosive charges were impractical. The fundamental insight that sustained mechanical force could achieve what single explosive events could not informed decades of development in both military and civilian applications. Several of the original vehicles survive in museums today. The Tank Museum in Bovington houses a Churchill AVRE, though not fitted with the rotating drum mechanism, which was typically removed post-operation. The Imperial War Museum's collection includes technical diagrams and specifications. Scattered across Normandy, concrete bunkers still bear the distinctive scarring pattern left by the drums, spiral grooves worn into surfaces that were meant to resist artillery shells. Normandy, France, June 6, 1944. A German soldier huddles in a concrete bunker, believing himself safe behind metre-thick walls, designed by engineers who understood ballistics, who calculated blast pressures, who anticipated every conventional weapon the Allies might bring to bear. He did not anticipate physics itself being weaponized. He did not imagine that concrete, that symbol of permanence and strength, could be reduced to powder by nothing more dramatic than a spinning drum and relentless pressure. In the space of a few minutes, his fortress becomes a trap, then a ruin, then a memory. No explosion marks its passing, just dust, vibration, and the grinding sound of inevitability. The British had solved an impossible problem not through greater firepower, but through greater ingenuity. They had created a weapon that destroyed fortifications without any explosions, and in doing so, they had demonstrated a fundamental truth of warfare. Sometimes the most devastating force is not the loudest, but the most inexorable. The concrete walls crumbled, and with them, the myth of the impregnable defense.